Alright, this is my attempt at making a DC motor for my Physics 2 project. I'll first start off with the design of the motor. So first of all, the shaft was designed out of a single piece of 5/8 hex stock. You can see it right there. I machined these pieces down here so I could press fit bearings on it. This surface underneath here was just machined so it's a circle, and then it's hard to see, but if we spin it around, this right here is a commutator made of 3 individual slabs of copper, and that copper is about a millimeter thick or so. Then the centerpiece, I drilled and tapped 6 holes, because this is if we take this out, see, it is a 3-turn motor. So there are 6 screws, 2 here, 2 here, and 2 there. Those are 8 mil. Then the wire you see here is 28 gauge wire with the epoxy coating on it, so it's non-conductive. And then underneath here we have the magnet. This is the biggest magnet I could find, because I'm not allowed to purchase the rare earth magnets because they will, break your hand if you use them. So that sucked. Then for power supply, I wired 4 9-volt batteries in series, which would give me 36 volts. And then this is just regular old, 16 gauge wire with some alligator clips that I soldered in there. So there's that. And then the frame is just, some 2x4 wood, no big deal. And there are these pipe clamps that I was going to use to actually bolt it down to make sure it wouldn't go anywhere, but I didn't end up using those because the damn thing won't work. So the theory behind it is, as we know, when current travels through a wire, it produces a magnetic field. And when those magnetic fields oppose each other with the magnet, it'll produce a force in either this direction or this direction, depending if the current's running if this is positive or negative, or vice versa. And that would cause the motor to spin. So I was not able to get mine to spin. I measured the resistance through the wires, which, by the way, each one of these is about 600 turns, so 600 revolutions, which is roughly, let's say, 800 feet of wire. So I used almost 2,000 feet of wire between all 3 of those. The measured current, we start out with current. The measured current is about 1 to 2 amps. That was using my my voltmeter. It was varying a little. The measured resistance was anywhere from about 7 to 8 ohms. Then on one strand, I actually did get 12 ohms. The calculated resistance was around 60. So that was way, way off. I went through and rewired 2 of these. These are brand new wirings. And then even under the screws, you probably won't be able to see, but there's electrical tape around the screws so the screw wouldn't scratch up that coating or anything. So I could not get it to work. There is, when you hook all this up, there is a slight magnetic field on this. You can tell, if you hold the magnet parallel, right next to it like that, it will move a little, just kind of like that, but it won't continuously, spin on its own. Couple theories why it might be doing that. Number one is obviously there's not a strong enough magnetic field. That could be due to there's not enough magnetic field produced through the wires. That could be because the magnetic field from the magnet itself isn't strong enough. There are a couple factors, but I could not figure out. This is pretty heavy. All said and done, my guess is maybe £1.5 pounds. So I mean, it is pretty heavy. So it doesn't surprise me that it didn't move. That is my attempt at a Physics 2 project.